this. All right. So if we look here, this whole piece, it's telling us the true radius. So that's going to be the true radius when we're looking at it kind of along its axis. So not from the end, because so this piece here where it's cut through isn't true. So we can't just sketch it here. We'd have to sketch some kind of ellipse and do that, and that's not going to work. So what we know though is that from this corner over, it's 33 along that surface to that center point, and then from that it's 60 degrees at an angle, right? So I have those two pieces of information. So let me come back here to there. Okay. So I know I need to come back 30 degrees here, and that's going to be my center of my circle, and it's going to go that way at 60 degrees. So if we look here under our different ways of creating construction stuff, I have a few options. So I have offset plane, I have plane at an angle. So maybe that sounds like that's what I need, right? So I need to create an angle. So, but what does that need? So I need to have, come on. I need to have a linear edge, axis, or sketch line to position the plane. So do I have any of that stuff right now? No.
Negative.
So I need to create something there. So I can either you come out here and create a sketch line or an axis, something like that. So we could do a sketch here, draw a line 33 over, and use that. But like I said, I don't like to use sketches if I can use features. Features are features, and so I prefer to use those. And so I can just do an offset plane from here, go back in 33. So I create a plane there, right? And now I can create an axis through two planes. So I can pick this plane and that plane. So now I have a pivot point for it. So now I can create a plane at an angle, pick that long one, and I need to be, is it 30 there? No, it's 60 there. So there we go. Right? So now I've created my plane. So now I have a plane there. And so if I draw on this plane, let's just put it there. You know, I can't trim the purple line. I don't need to trim the line. I've got my shape here, whatever. So if I want to extrude this, and I go to extrude, I can tell it to go to object over here, perfect. But over here, it is either going to start there or go there. If I tell it to go, you know, to object, this one, it's not going to do anything because it's crossing through it, right? Half of it's not to, and half of it is. So it's confused. It can't go both ways at the same time. I mean, I could use the two sides are symmetric, but that's going to make it go up in and out, but it's not going to stop here at this edge. And so what I did is, instead of sketching there, I just pulled another plane out here somewhere, just out past the part. So now I can sketch on this.
Would that be an offset plane?
Yep. Yeah, so I just did a regular offset plane. And now I can sketch there. Tell it to be vertical between there and there. Trim off the bottom. And now I can extrude it. And so my start is from an object here, and my end is to an object over here, and there it goes.
So is the theory because it's offset and not already on?
Yeah, because it's not cutting, this one's cutting through the surface, and so I can't work. So it has to be out past the surface. So it could have been here, or it could have been in here. So if I say okay, that's great. So if I made that plane, instead of bringing it out here, if I made it in the middle of the part, same thing, it works. It just doesn't work if it's touching the edge. Oh, so now it broke. So you turned yellow down here, it broke. But as soon as I get it out past the part, now it's fine. And if it's inside the part, it's fine. Just that sketch can't go through that edge where it's wanting to start and stop. Okay? Does that make sense? So that's basically it. And then we do the same thing with the hole. We have to sketch on that same plane, put in our hole location. So create a sketch, boom, and then, project my arc. Now I get my center point, and now I can do my hole from that center point all the way through whatever size it is. And there it goes. Oopsie. I need to do it on that first plane, right? So I'm just going to do redefine sketch plane, and I want it to be on. Oops. This is where that plane needed to be on the outside. If the plane's on the inside, it doesn't work very well. So if I make the plane out here, though, now I can do. There we go. So now it starts out there and goes all the way through. Okay? So that's one reason I put it on the outside, not inside. So I can do the hole. All right? Any questions on that? Does that make it a little bit more clear? Yep.
A little bit. In the real world, if you were given a drawing like this and you were going to manufacture the part, let's say you were as green as you could possibly be in the industry, and you drew that circular bump there at the top, just on the face, that's obviously not gonna work, because that's not the true radius.
Yeah.
Is there a check and balance of any sort that?
If they would see, because it'd be if you just drew a regular arc here and then tried to do a loft, or then drew a line here and swept it, it'd be skinnier. It wouldn't be the right shape.
You'd be able to.
Yeah, the bosses would know right away.
Okay.
You'd get it apart and it would look a lot different, because let's try that.
I tried it, yeah, you can see it like tapered it.
So let's say that. Just say I draw here, I just draw a circle. Dimension. So if I did that, and then let's see, I create a sketch here. Really doesn't matter where that is. That dimension. And then I do a sweep there. So you can see the shape is different. Let's see. By that much.
I can't say I would recognize that right away.
Yeah, and so they might not see right away, but when they put a radius gauge on it, instead of being the right radius, it would be, so instead of being a radius 19, it would be a lot smaller.
So that's part of the process, they'll print a test and then they.
Yeah, you'll make one and try it out and see.
Measure everything.
Because when you're out in the real world, you're gonna make the part. Whoever's making it, they're gonna have to check stuff, and so they're gonna see it says true radius on there. So they're gonna put a radius gauge. Where those go? Right, a radius gauge on it, and they're gonna see, oh, it's too flat, or it's, let's see, where is it? It curves in too much. It doesn't follow the full radius. It drops off on both sides, right? Oh, something's off. Or they're gonna put it in a CMM machine. So kind of like what you guys did in 32. So those of you who haven't done it yet, 32 is the reverse engineering class, and we're kind of changed that to be reverse engineering / inspection. Because I think, but they'll stick it, they'll laser scan it, or they'll put it into a machine that'll go through and automatically probe it, and it'll see like, oh, this isn't right. But that's where kind of having someone to, yeah, double check it and say, oh yeah, that's, something's off here, or whatever. So, yeah.
You do like 50,000 of them or something.
Yeah, but they would do,
Yeah, check one.
they would do one and check it, and if they're doing it for, if you're doing it in-house, you're gonna have the engineer or whoever designed it, they're checking that first one to make sure it was right. If you're doing it for like an outside person, you're gonna do one and send it to them to have them check, just to make sure that you're meeting their quality standards. And then, or you might do like 5, a small run, send them off, make sure that they work, and then they'll say, okay, yeah, now give us the rest. They're not just gonna have you do 1,000 of them sight unseen. But this is where being able to read the drawing is important, because if you did that and you drew it the wrong way, and you made a bunch of symptoms, they're not gonna have to pay for them, because the drawing doesn't show that. So, because they're gonna call in someone and say, what does that mean? It means along the way, not sideways. And like, oh, yeah, these are all wrong. So, any other questions? Yes, no? All right.